Hello everyone, this is Dr. Sunita Bulla. In this session, we are going to discuss about containerization. Before going to discuss about Docker, we should know what is a container and what is a containerization process. Let's start from scratch. First of all, booting. We already know what is a dual boot. Uh, this dual boot allows the installation of two different operating systems in a single computer. This dual boot is useful when applications require specific OS environment, but here the major drawback is that only use one operating system at a time. If you, for example, in your computer, if you installed two operating systems, one is Linux, second one is a Windows. If you want Windows, uh, you need to log out or terminate Linux operating system. If you want Linux operating system, you need to log off Windows operating system. So now this is the drawback. Here switching is required. To reboot, we can we can use one operating system. It is a very time consuming process. If you want Windows, you need to reboot Windows operating system. It takes a time. It's taking 5 minutes or 4 minutes of time. It is not efficient for the development and testing on a different environment. For example, if you are working on a full stack application, the front end is deployed on Windows operating system, back end is deployed on Linux operating system. Let's assume if you want to edit front end related things, you need a Windows operating system, and if you want to edit back end related things, you need Linux operating system. Like switching with the two operating system is a very difficult process. So now it is a time consuming process. It is a very this drawback, whatever this drawback leads solution to the new concept. That concept name is virtualization. And now, so this virtualization is a technology and platform. This technology allows you to run multiple isolated operating system on a single physical computer and physical machine. It is a process to create a virtual versions like it it shares physical resources. Nowadays, not only servers, this virtualization concept implemented everywhere. Now, like a server creating, storage devices creating, and sharing network environments. Like now, nowadays, everything has a virtualization. Now, see, this is the example before virtualization. For example, let's assume this is our computer. This is our computer. Now this computer, as a developer, I want to execute my full stack application. Right? To execute a full stack application, what I need, I first of all I need one computer. So now the computer contains CPU, memory, hard disk, and this is has a hardware. Now next one on the top of the hardware operating system required. On the top of the operating system, I will install all the application related tools like VS Code, Eclipse, MySQL, and after that I will deploy this particular this application. I will implement application. I will deploy the application. Now here to do this task, I need one server dedicated to the server is dedicated to one single operating system. Okay, this is lead to it is utilizes hardware resources, and at the same time we need to maintain one single server every time. It increases the cost, and it uses the space, power consuming, and maintaining the application. For example, let's take any organization. For example, Wipro. So Wipro is the organization. The Wipro is working on hundreds of applications. Now, for Wipro having hundreds of applications, if they want to deploy their application, they need to maintain hundreds of servers, every server having hardware resources, every server having operating system, and the top of the operating system, and we will implement the application, will deploy the application. It's like a traditional model. It's like a traditional model. Now, then same example we will discuss with the after virtualization. See here, this is the figure related to the virtualization concept. First of all, this is a simple, let's say you small environment. This is your local system. Okay, now what happens? Our system having CPU, memory, NIC card, and hard disk. Here, now this computer having virtualization concept. Okay, now what is a virtualization? Exactly what is a virtualization here? Virtualization is a concept. This by using this concept, we will split our hardware resources for different virtual machines. For example, this computer having two virtual machines. One is a this virtual machine. Second one is this virtual machine. Let's assume you have a 4 GB RAM, 100 GB hard disk. So now this is your computer hardware. If you want to create a virtual machine, there are two virtual machines, right? Whatever your RAM, this RAM is shared 2 GB to this VM, 2 GB to this VM. Similarly, hard disk, 500 GB hard disk for this VM, and 500 GB hard disk for this VM. So now, what is a virtualization? Virtualization is a concept to convert like a whatever to utilize your hardware resources for multiple virtual machines. So this is the concept of virtual machines, like a virtualization. Now, to implement the virtualization, we need tools. We need framework or tool. That tool is called hypervisor. If you want to do the virtualization, we need hypervisor. This hypervisor, by using this hypervisor, we can able to implement virtualization. So now, first of all, what is a hypervisor? So now, hypervisor is nothing but it is a one software, or we can say it is a tool or software. Okay, now this by using this hypervisor, we can we can we can install multiple operating systems on a hardware on the top of the hardware that it shares the hardware to multiple operating systems. And now the hypervisor, there are two types of hypervisor: bare metal hypervisor, hosted hypervisor. Bare metal hypervisor, we called it as a type 1 hypervisor. Hosted hypervisor, type 2 hypervisor. The bare metal hypervisor is used by the organizations like Amazon, Google, like Azure, like for example, different cloud providers are there, right? Now, the cloud providers are using bare metal hypervisation concept. So, how it will work exactly means, first of all, hardware. Now, hardwares like RAM, hard disk, these are the hardwares, right? On the top of the hardwares, we will install the hypervisor. Now, with the help of hypervisor, whatever hardware will split into the multiple virtual machines. Now, for example, take a AWS. So now AWS data center having bundles of hardwares. Like the data center is a full of hardwares. On the top of the hardware, they will install the hypervisor. So now Citrix Zen server. Let's take example. They install Citrix Zen server on the top of the hardware. So now by using Citrix Gen server, So they will split their hardware with for virtual machines. As a AWS customer, I will log into my account. Simply, I will create the virtual machines. Now, if I selected 1 GB RAM, they will allocate 1 GB RAM hardware to my virtual machine. If I selected 2 GB RAM, they will allocate 2 GB RAM hardware to my virtual machine. Who will do these things? Hypervisor will do these things. Now, this is the hypervisation, virtualization concept is used by the organization. This is called type 1 hypervisor, that is the bare metal hypervisor. Next one, type 2 hypervisor. As a developer, we have a little small environment. If your organization is very small, so we don't need any bare metal related hypervisor. We need hosted hypervisor. First of all, if you want to use the hosted hypervisor, what is the execution flow? First, we need hardware. On the top of the hardware, we need to install operating system. Let's assume Windows operating system. And the top of the Windows operating system, we need to use a hypervisor. So, example here, VMware, VirtualBox, these are the hypervisor softwares. Now install the hypervisor software on the top of the Windows operating system. By using this hypervisor, we can able to create virtual machines. Whatever hardware, that hardware is related to the operating system, same hardware is used to create a virtual machines also. This is called hosted hypervisor. So now if you want to, as a developer, if you want to implement the application, for example Java full stack application, so I need two virtual machines, one virtual machine for front end deployment, another virtual machine for back end deployment. Now what I will do now, so first of all I will create two virtual machine by using the virtual box, and on top of the VMs I will deploy the application. So this is the uh, concept of hypervisor. This hypervisor is especially to implement virtualization concept. Now what is the virtualization based on the hypervisor? Now we already discussed this is a bare metal type 1 hypervisation. So now here on the top of the infrastructure, we need to install the hypervisor. With the help of the hypervisor, we will create the virtual machines. Now, if you want a virtual machine, guest operating system is a mandatory. For example, if I want to create one EC2 instance inside the AWS cloud, now I need to select one operating system, either Windows, Linux, or any operating system. So now this is the virtual machine. If you want to deploy the application in the virtual machine, now what we required guest operating system. On the top of the guest operating system, we will deploy our application. Now next one, this is the hosted hosted virtualization. First of all, infrastructure. Top of the infrastructure, OS virtual box, and the top of the virtual box we need to create one virtual machine. Even though here also we need guest operating system to deploy the application. So this is the virtualization concept. Now, what is the purpose of virtualization? Virtualization aims to create virtual machines. As a developer, we need virtual machine to deploy the application. Now next concept is containerization. If you understand what is a virtualization, then it is very easy to understand the containerization. First of all, virtualization, containerization, our aim is only one, deployment of the application. Now here, virtualization used to create VMs, right? These VMs are used to deploy the application. Now similarly here, the whatever the containerization used to create a container. The container is used to deploy the application. Our final target is deployment of application. Now here in the containerization, so first of all, um, what is the drawback of virtualization? Now here, if you want to deploy the application, if you want to deploy application here, we need one OS, one operating system. Then the operating system consuming large portion of hardware, right? It's you consuming large portion of hardware, and it required booting time, and it required memory, CPU, and if you are working on a microservices and a cloud DevOps, this environment is not suitable. Like microservice has to communicate with the multiple services like a front end, back end, uh, database, and it will communicate it with the other application. If you are working on those kind of application, this virtualization concept is not suitable. It taking lot of time to communicate or create an implementation purpose. Now here the container. So now first of all, the containerization. What is the containerization? Is nothing but the containerization is nothing but it is used to create a container. Okay, that container um, having application code, operating system, all the dependencies needed to what needed to application. For example, let's take a one food packet, right? The food packet contains rice. Along with the rice, it contains all the curries, whatever required uh, to eat the food, right? Similarly, here the container having application code. Along with the application code, it has a operating system, it has a softwares, it has all the libraries, it has all the dependencies, it has all the packages, whatever required to run this application, everything is available in the container. Okay, it's not depending on any operating system. Okay, its container is a packet. The packet contains all the environment, entire environment to execute your application. So now, whatever container here the container is a process. It's a very to create a container. It's a very lightweight. It is alternative for the virtualization concept. Okay, if you want to deploy the application, instead of virtualization, we need one alternate method. That method name is called containerization. If you are using containerization, then it is faster deployment, and it needs lower resources, and it is very simplified for the scaling environment. And this containerization is suitable for DevOps and microservices. Now see is an example of the containerized application. Okay. Now first of all see here, if you want to containerize the application, we need hardware, right? Let's assume this is the your laptop. Okay, the laptop contains my laptop contains 4 GB RAM, 1 TB hard disk. Now here this is your infrastructure. In the top of the hardware, one operating system. Like my laptop having Windows operating system. That operating system called as a host operating system. On the top of the host operating system, we will use the containerization tool. Okay, for virtualization purpose we need hypervisor, but here for containerization purpose we need containerization tool. The tool name is Docker. Now on the top of the Docker we will create the containers. Say app A is one container, app B is a one container, app C is a one container, app D, app E, app F. So these are the containers. So now see here this container. What is a container? The container having operating system. That operating system we called it as a base image. Then it has all the dependencies. It has all the software. So now when you run this container, the container already having the base image. You no need to worry about operating system. It inbuilt, it has operating system. When you run this container, it will hit on the host operating system kernel and it will execute, and at this not only execute, it will deploy the application in the Docker environment. Okay, that is called containerization. Now let's see what is the difference between containerization and virtualization. Now here as a developer will discuss in terms of application. Okay, now first of all, if you want to deploy the application, now if you are using virtualization, we need one virtual machine, and the top of the virtual machine we need operating system, and the top of the operating system we will deploy the application, right? So now it launching the operating system, closing the operating system, it takes the time, more time, and every time we need internet, and if you are using local hypervisor, now we need if you fail your uh, if you fail your virtualize hypervisor tool, then and everything is a crash, right? Now next one, when coming to the container. So now first of all, this is the hardware. On the top of the hardware, it has a host operating system or Windows operating system. Then top of the hardware, Docker. The Docker contained application. This is a very lightweight application. It's not depending on any operating system, right? It's a Docker tool. It's a Docker tool. If your Docker tool crashed also, if you created container, no need to worry, just uninstall the Docker, install it again, we can use this application. Now, so now this is the heavy weighted virtualization, is a heavy weight. Now it's taking lot of time to start and stop virtual machine. Second one, in the container, it starts within the fraction of seconds. When you type the command, it will start, and if you want to stop, it takes the fraction of minutes. Alright, next one, it's need entire OS to run the application. In the container, we no need to worry about the OS. It built it having the base image. Now, this is our main concept, container. We already discussed what is a container. The container is nothing but it is a one packet. That packet contains uh, application. Let's say in Java full stack application. If you want to run the Java full stack application, it has a base operating system and all the softwares. Then at the same time, all the dependencies, whatever required to run the application, everything is available inside the container. Container was virtual machine. The container is isolated. It's like not depending on any OS. It's very lightweight. It's very easy to start and stop, and it's a version control. I mean, very easily we can communicate for the containerization workflows. Virtual machine. If you want virtual machine, we need full OS, and the full OS contains in terms of GBs, and containers available in terms of MBs. Start and stopping time very. If you want to launch the virtual machine, it takes the minutes. If you want to launch the container, it takes the seconds. Next, let's take it is an example of container, base image container. And now here in this base image, Ubuntu, base image of Ubuntu operating system. So first of all, if you want any operating system, for example, if you want to launch operating system, then it needs 2 GB, 3 GB size is it occupies GBs. Alright. So see here, this is the Docker base image Ubuntu container. So it contains 28 MB. It contains 28 MB. It's a very less. Okay, the container uses this kind of base images. That is the reason it is a very fast. Okay, if you want to run the container, the application deployed on this base image, the base image size is 28 MB. Then to download the 28 MB is a very less time. It takes very less time. Now, when you are creating a Docker, uh, first of all, we should know two environments. One is base image environment, second one is host operating system. Both are operating systems only. Now, what is a host operating system? What is a base operating system? Now, see here, let's see this example. In this example, in this example, first of all, see here, this is a host operating system. On the top of the hardware, whatever hardware, we are uh, we are installing the host operating system, Windows operating system. So now uh, in the top of the Docker we have a container. The container having base image. The operating system name is base image. So now host operating system is nothing but whatever operating system in the local system, that is called host operating system. Whatever OS inside the container, that is called uh, that is called container operating system, like a base image. So now first of all, base image. When you are handling the base image contain these are the files: bin, sbin, etc, lib, user, var and root. So now bin is used to how many files are there, how many containers are there, everything will see inside the bin folder. Next one, var and root. There are many files and folders are there, but bin, var, root, these three are we are using. We are using. First of all, if you are working with the root, we need to deploy our application inside the root folder only. Okay, first of all, we should know when you are working with the containers, what is a base operating system. Second, what is a host operating system. So now base operating system related to the deployment of the application. The host operating system is nothing but it is a like it contain the local project, and we need network related concepts. What are the system calls, namespaces and control groups? We'll discuss these things later. First of all, so now base operating system, host operating system, these there are two environments. Now, host operating system is a source and a base operating system is a destination. If you want to deploy application in the Docker, we will send the application code from the host operating system to the base operating system. It's a very important point. Two environments. Now we all are familiar with the Git and GitHub, right? So local Git is a source and GitHub is a destination. Similarly, here local operating system is a source and base image is a destination. Finally, containerization tools. Now here there are different tools are there to use it to implement containerization. Now here Docker is a one of the tool. It's a very famous tool to implement the container concept, and Podman is a one of the alternate tool. Instead of Docker, we can use the Podman also. Next, Kubernetes also used to create a container, but not a small use cases. The Kubernetes is a orchestration environment. This environment is uh, used to implement like orchestration, like a vast deployments happens in the Kubernetes. We'll discuss these concepts in the further sessions. So in this session, first of all, we should know what is a virtualization. Virtualization is a concept to create a virtual machines. What is the purpose of virtual machine? To deploy the application. Next one, what is a containerization? Containerization is used to create a container. Now that containers are used to deploy the application. So both are same. But if you are using virtualization, virtual machine, we need entire OS. But it's taking lot of time and lots of hardware, and it is also cost also very high. Next, when you are using container, so we no need any operating system. It's a lightweight, very fast to the deployment, and the maintenance also easy and cost effective. Thank you.